Hi everyone. Today we're going to study one-sided limits. We learned last time that this is the notation for limits. We read this as the limit of the function f of x as x approaches a equals the value L. To have a limit L as x approaches a function f must be defined on both sides of a, and its values f of x must approach L as x approaches a from either side. Because of this, ordinary limits are called two-sided. Let us now define one-sided limits. Suppose we want to find the limit of a function f of x to the right of the point A. The notation is this: the limit of f of x as x approaches a, and this a will have an exponent of positive sign, and we call this right-hand limit. Also, to find the limit of a function f of x to the left of the point A, this is the notation: limit of f of x as x approaches a, and this a will appear like having an exponent of negative sign. We call this left-hand limit. Let us now consider the function y equals f of x represented by the graph. Let us now find the limit of the function f of x as x approaches 1 from the right. Let us locate 1 in the x-axis. Here it is. Again, we call this the right-hand limit. Now, when x approaches 1 from the right, the graph is approaching a value of y, and that is 1. So we write here 1 as the answer. Letter B, let us find the limit of f of x as x approaches 1 from the left. Again, we locate 1 in the x-axis, and we call this the left-hand limit. When x approaches 1 from the left, the graph is here and it is approaching a value which is 0 in the y-axis. So we write here 0. So these are the answers for the given limits. Now let us consider this theorem. A function f of x has a limit as x approaches a if and only if the limit of f of x as x approaches a from the right side exists, and the value is L. Also, the limit of f of x as x approaches a from the left exists, and the value is also L. In other words, the right-hand limit must be equal to the left-hand limit, and the common value is L. In that case, we can say that the limit of the function f of x as x approaches a, this is now the two-sided limit, is also that same value, which is L. Now, suppose the right-hand limit and the left-hand limit are not equal. So we say that the limit of f of x as x approaches a does not exist. In some books, you will see the symbol D, and E. This means does not exist. Take note also that when the right hand limit is not equal to the left hand limit, don't write answer as 0. Again, what you're going to write is the word does not exist. Let's go back to our example a while ago. The right hand limit is equal to 1, while the left hand limit is equal to 0. So when we write the limit of f of x as x approaches 1, this is now a two-sided limit. As per our theorem, we can compare the values of the right hand limit and the left hand limit. We can see here that they are not equal. So the answer here does not exist. Let's have another example. Example D, limit of f of x as x approaches 2 from the right. Let us identify the number 2 in the x-axis, and it's here. The values are coming from the right. We can see that when x approaches 2, the graph is here and it is approaching a value of y which is equal to 1. So we write here 1. Next example, the limit of f of x as x approaches 2 from the left. So the number 2 is here. When x approaches 2 from the left, the graph approaches a y value which is 1. So we write here 1. Now, example F, the limit of f of x as x approaches 2. This time, this is a two-sided limit. So we will compare the values of the right hand limit and the left hand limit, and we can see that they are equal. And the value is 1. We will just simply copy this value and we will write it here. And that is the answer. Example G. The limit of the function f of x as x approaches 3 from the right. The number 3 is here, and we will consider those values of x that approaches 3. Then looking at our graph, it is now approaching a value of y which is 2. So we write here 2. Example H is the limit of f of x as x approaches 3 from the left. So the number 3 is here. When x approaches 3, the graph is approaching a value of y which is 2. So we write here 2. Example I, the limit of the function as x approaches 3. This is now a two-sided limit. And we can see here that the right hand limit is equal to the left hand limit. And the value is 2. So we will copy this and write it here. This is now our answer. Example J. The limit of f of x as x approaches 4 from the right side. So the 4 is here. When x approaches 4 from the right, from our example, the graph is not defined. So we write here, does not exist. Example K, the limit of f of x as x approaches 4 from the left side. So when x approaches 4, the graph is approaching a value of y which is 1. So the answer here is 1. Now, example L. The limit of f of x as x approaches 4. We know that this is again a two-sided limit. comparing the values of the right-hand limit and the left-hand limit. They are not equal. So in here, we will write does not exist. Example 2. Evaluate the limit of the function square root of x minus 2 over x minus 4 as x approaches 4 using a table of functional values. Note that x approaches 4. So we are going to write the table that looks like this. We have x here, f of x here, another set for x and f of x. This is one pair, this is another pair. For the first pair, with regard to the x, we're going to write values of x that comes to number 4 coming from left. So we write the values as 3.9, 3.99, 3.999, 3.9999, 3.99999. Given these values, we will solve for f of x. That means our function, here it is, the square root of x minus 2 over x minus 4. Let us find the corresponding values of f of x. For example, we want to get the value of f of x when x equals 3.9. That means we evaluate f of 3.9. So that will be the square root of 3.9 minus 2 all over 3.9 minus 4. We know that we change all x by the value 3.9. Using our calculator, the numerator is simplified as negative 0.0251582,342 all over negative 0.1 in the denominator. The quotient now is positive 0.251582,342. Then we copy this value in here. So, same pattern we will do for the other values of x. Then we can write now the values of f of x respectively. And here it is. Now for the second pair of x column and f of x. We write the values of x that comes to number 4 but coming from the right side. The values are 4.1, 4.01, 4.001, 4.0001, 4.00001. I hope you can see the pattern here. Now, let us find the corresponding values of f of x when x has these values. So, f of x will be like this. Now, for the first pair of x and f of x, we look at the f of x values. We can observe that when x values comes very near to 4 coming from left, the values of f of x will come to the value 0.25. So we can say that the limit of the square root of x minus 2 over x minus 4 as x approaches 4 from the left equals 0.25. Now what about the values that comes from the right? Looking at our f of x, as x comes to number 4 coming from the right, the values of f of x will come to the value 0.25. So we can write like this. The limit of square root of x minus 2 over x minus 4 as x approaches 4 from the right is equal to 0.25. Now let us get the value of the two-sided limit. So we write here, since the left side limit is equal to the right side limit, and both of them equal 0.25. Then the limit of the square root of x minus 2 over x minus 4 as x approaches 4 is equal to 0.25 also. Example 3. Given the function f of x equals x plus 1 as x is less than 2. Another function x squared minus 4 when x is more than or equal to 2. We have here three problems. Let's begin with the first one. The limit of the function as x approaches 2 from the left. Notice that we have here a piecewise function. Let us evaluate the limit from the left side. Now the question is, which of these two functions we're going to use? Take note that when we have here the less than symbol, that pertains to the left hand limit. While the more than symbol, it means that it pertains to the right hand limit function. Now, for the limit of f of x as x approaches 2 from the left, we're going to use this function x plus 1. So we rewrite our problem as the limit of x plus 1 as x approaches 2 from the left. Then we evaluate this. We substitute the number 2 to the x. So we have now 2 plus 1, which is equal to 3. This is the answer that we will write opposite the first problem. Let's go now to the second problem. Limit of the function x approaches 2 from the right. So we're going to use the second function. So we have now the limit of x squared minus 4, x approaches 2 from the right. We evaluate now this function. We substitute x by 2. So we have 2 squared minus 4. 2 squared is 4 and 4 minus 4 is 0. So the answer here is 0. Now let's go to the third, the two-sided limit. Limit of f of x as x approaches 2. From here, we need to compare the two values, the left-hand limit and the right-hand limit. We can see that they are not equal. So we write, since the left-hand limit is not equal to the right-hand limit, then the limit itself, or limit of f of x as x approaches 2, does not exist. Or to simplify, we may write d and e. This is does not exist. So this is the answer for the third problem. Example 4. Using the diagram below, answer the questions. This is our graph that pertains to a single function. Number 1 question. The limit of the function f of x as x approaches negative 5 from the left. Here we have some clues on how to solve this. Number 1, look at x-axis and let us find as x approaches a. Meaning, in problem 1, x approaches negative 5. In the x-axis, negative 5 is somewhere here. And then step 2, we look at the graph. Meaning, this is the graph. We can have an imaginary vertical line here that passes through the negative 5. So, this is the corresponding graph that comes to this point when x comes closer to negative 5. Now, number 3, we look at the y value. That means the y value here is 2. So, the answer here is 2. Second problem. Limit of the function x approaches negative 5 from the right. So, step 1, the negative 5 is here. And then, the corresponding graph is here when x is coming close to negative 5. And then, we look for the y value, and that is same number 2. So, we write here 2. Then number 3, two-sided limit. The limit of f of x as x approaches negative 5. In this case, we compare the values of left-hand limit and the right-hand limit. We can see that they are equal. This is the same value for the two-sided limit. So we write here 2. Now, number 4. F of negative 5. Negative 5 is here. On the graph, there is a point. Also, there is a line, but there is a hole at that point when x equals negative 5. That means we are going to get the value of this point when x equals negative 5, and that is 1. So we write here 1. Number 5. Limit of the function as x approaches negative 2 from the left. Negative 2 is here. The corresponding graph when x comes close to negative 2 is here. So we will get the corresponding value as negative 1. So the answer here is negative 1. Problem 6. Limit of the function as x approaches negative 2 from the right. So the negative 2 is here. The graph will be this graph. And when we have an imaginary vertical line that passes through negative 2, this is the corresponding graph when x comes closer to negative 2. Then we find the y value, and that will be 4. So we write here 4. Number 7. This is a two-sided limit. So simply we compare the values for left-hand limit and the right-hand limit. We can see that they are not equal. In that case, we conclude that the limit itself does not exist. Problem 8. F of negative 2. This means what is the exact y value of the function when x equals negative 2. So on the graph, the negative 2 is here. Here we can see a solid dot. That is a point, and the y value is 2. So we write here 2.